All right. Hi, everyone. I'm Connor, and today I'm going to be talking about some work about stereotypes in human AI co-writing. So as some of you may know, there's been some really great work in the past about measuring and mitigating social biases and stereotypes in language models. Other really cool work has looked at how co-writing with a language model can affect various aspects of human writing. So this includes things like the opinions expressed in writing, sentiment, etc. But it's sort of unclear from the prior work how social biases or lack thereof in a language model affects co-writing. So in this work, we were particularly interested in how users interact with anti-stereotypical predictive text suggestions that basically try to counter potential biases in participants. So in particular, we're interested in whether participants potentially accept the language model suggestions, regardless of the direction of the suggestions. Basically, prior work has shown that users will accept suggestions that social media is either good or bad for society, kind of regardless of the direction. But it's also possible that participants might selectively reject the anti-stereotypical suggestions, basically going with what the language model says when it conforms to their biases, and rejecting suggestions when they challenge stereotypes. So yeah, we're kind of interested in which side of this anti-stereotypical suggestions lie on. So to better understand this, we conducted a user study where people wrote stories with or without the help of a predictive text system. So you would get kind of the prefix of a story like you can see on the screen here. So this one is about a president. And if participants receive predictive text suggestions, we prompt the model on the back end to either pro-stereotypically suggest that the president should be described using masculine language or anti-stereotypically described using feminine language. And then, among other things, we can measure kind of the final gendered language used to describe this like president character. So let's see what happened in our study for this particular writing scenario. On this graph, we're going to see on the left side the proportion of stories where the president is described using masculine language, and on the right with feminine language. And the colors of the bars will show whether or what kind of suggestions the participant received. So first, we see that if the participant receives no suggestions or suggestions that the president should be using masculine coded language, we unsurprisingly see that participants overwhelmingly write about masculine presidents, and we can see that the suggestions aren't really changing anything. So if they were going to be writing about a masculine president anyway, the suggestions aren't really changing anything. However, we do see change to participant behavior with the anti-stereotypical suggestions trying to kind of push them in the feminine direction instead. In particular, we see a significant drop in the proportion of masculine presidents and a marginally significant increase in the proportion of feminine presidents when given these anti-stereotypical suggestions. So yay, we can go home happy, right? Not quite. Even with these suggestions, we still see significantly more masculine presidents than feminine presidents with these suggestions. Yeah, so, and this continues to be true across many different writing scenarios, where basically we see that even with these 100% anti-stereotypical suggestions, participants are often still writing pro-stereotypically gendered characters as they sort of ignore and override these anti-stereotypical suggestions. And just as a quick caveat, in this setting, we're talking about anti-stereotypical suggestions, which is not the same thing as what we would expect to see from a debiased model. Basically, if we think about removing bias from the model, it might be doing something like suggesting either a gender option kind of uniformly at random. So our results are not showing what would happen if you give people a debiased model, but kind of upper bounding the effect, the positive effect that a debiased model might have in co-writing. So the bottom line is positively, we do see that anti-stereotypical suggestions can lead to more anti-stereotypical writing. However, even with 100% anti-stereotypical suggestions, participants often overrode these suggestions, showing that essentially just debiasing the model on the technical side will not necessarily lead to de-biased writing at the human AI level. So more involved interventions might be necessary to encourage participants to engage more with potentially challenging model suggestions. So yeah, thank you very much for listening, and here's the QR code if you'd like to see the full paper. Thank you.
Good morning, everyone. My name is Imi. I'm a PhD candidate from the College of Information. As Beth introduced, I will be giving 2 talks in a row, and both are on similar topics for non-native speakers. So my first talk is titled Displaced Contributions, Uncovering Hidden Hurdles to Collaborative Writing Involving Non-Native Speakers, Native Speakers, and AI-Powered Editing Tools. I'm presenting this work on behalf of my co-authors, and this work was published at CSW 2024. Collaborative writing is a common practice across different contexts such as workplace, classroom, and research. Today, collaborative writing often occurs in a shared working language involving both native and non-native speakers across the world. Distributed co-writers often take turns to edit their joint document and collaborate asynchronously. In this context, language diversity is likely to benefit content production at the group level for reasons such as diverse perspective and also interactive meaning-making opportunities. However, for non-native speakers with limited language proficiency, they may find it challenging to make contributions for reasons such as their difficulty to fully manage the nuances of the work and the diminished sense of social status in the collaboration. So in this work, we aim to identify ways to fairly interpret and also enhance how non-native speakers contribute to collaborative writing tasks. From prior work, we observed that non-native speakers' contribution to written contents often appear limited when measured only at a lexical level. This looks like small amount of writing, lack of complexity in their writing, and also the need for vocabulary and grammatical help. So we considered 2 alternative levels of assessing contributions based on Erving Goffman's theory of footing. So this theory delineates language production into several aspects, including ideation, that's the idea a person is trying to convey, and expression, that are the specific words people use to convey the ideas. So for native speakers, they're more likely to manage both aspects of language production all by themselves. However, for non-native speakers, they're likely to require external support to manage the expressional aspect of their language production. So consequently, because they have challenge with the expressions, that can obscure their ability to actually generate ideas. So in this work, we explore 2 external factors that aim to enhance non-native speakers' management of the expressional aspects of their language production. The first is collaboration structure with native speakers, and the other is the use of AI-powered editing tools. And in this talk, I will mostly focus on collaboration structure. To elaborate on collaboration structure, we're curious about how will non-native speakers' contribution differ when they take different positions in the turn-taking order with a native speaker. So we manipulated the turn-taking structure in 2 ways. Some of the non-native speakers acted as early movers ahead of the native speaker, and some of them acted as a late mover after a native speaker. With that design, we conducted online experiment involving 32 dyads of 1 native speaker and 1 non-native speaker of English. Each dyad completed a collaborative writing task over 5 days, and each person completed a post-task survey and interview. And we manually coded each writer's ideational and expressional edits to the joint document just to understand how they were doing the writing. So one of our core results is a late mover disadvantage experienced by non-native speakers. So their ideational edits were suppressed when taking a later turn, although we do see when they take the very initial turn, they are likely to produce a lot of ideational edits. And this result was echoed in participants' interview reflection. For instance, one participant reflected that, I played a supporting role by inserting the ideas I can think of into my co-writer's writing. However, it wasn't always possible to integrate my content. After my co-writer's first turn, I saw they had already put together an impressive piece. So I searched for relevant materials during my turn, but I wasn't sure about the right places to integrate them. And at the same time, we do observe a lot of non-native speakers to use AI-powered editing tools. However, these tools did not exempt them from the disadvantages they faced. Non-native speakers faced challenges to assess and adopt the outputs from these tools. And the usage of these tools also misrepresented non-native speakers' language proficiency and ability to the native speakers. Here I will illustrate just one example. This is a non-native speaker who went through 5 different versions of their Japanese input and used 2 different AI tools to eventually write 5 English words, "I am confident of myself." This entire process took them 5 minutes to complete, and the person reflected in their interview that, "I have to admit I did not arrive at the most satisfying answer. The final sentence should be close to what I wanted, but I wasn't entirely sure. It took me a long time to craft the sentence. I thought I'd better stop there." So with these high-level results, our key takeaway is that in collaborative writing involving non-native speakers, fair interpretation of a person's contribution must consider inputs beyond the lexical level and the interpersonal effects of AI-powered editing tools. And I want to highlight that non-native speakers' potential to make ideational contributions may be suppressed by lexical measures and the late mover disadvantage. And we should structure collaborative writing workflow to coordinate different aspects of the writing process. And with that, I'll conclude this talk and acknowledge this work was supported by the National Science Foundation. Thank you. Hi again, it's still me. So my second talk is titled "Sustaining Human Agency Attending to Its Cost: Investigation into Generative AI Design for Non-Native Speakers' Language Use." And again, I'm presenting on behalf of my co-authors, and this work was published at this year's HCAI. In this work, we focus on machine translation as a system that generates content in a target language to help users navigate and mitigate language barriers. As I have alluded to at the end of my last talk, for non-native speakers who have not achieved full proficiency in a target language, they may face a loss of agency when using systems to assist with their communication. Conceptually speaking, although non-native speakers can formulate their thoughts in their native language, machine translation generally controls how their messages are represented in a target language. So our work explores different human-machine translation interfaces that enable non-native speakers to influence machine translation outputs in various ways to sustain their agency when using machine translation. We draw on Bandura's social cognitive theory of agency to inspire our design that modulate people's behavior and preserve agency. This theory states that humans have the ability to contribute to their environment through purposeful actions. And this exercise of agency requires and is also dependent on certain resources from people, such as the knowledge they have or the materials they have. Following this agency resource link, we examine non-native speakers' language resource to design for their agency in interaction with machine translation. Let's look at native speakers as a reference point. They would have language resources for, it's not showing on the slides, but they would have language resources for recognition and for production. And the recognition is to see if there are any issues in the certain content, and the production is to produce necessary correction to make the content look good to them. However, for non-native speakers, they may still have the same language resources for recognition. That's the solid red color on the left. So meaning they can recognize issues in the content, but they may have troubles to produce necessary correction to make things look good for them. And that's the lighter color that said language resources for production. So given non-native speakers' language resources composition, we explored 3 different human-machine translation interfaces that enable people to influence translation outputs with varying scopes of resources. And I'm using these different color squares to represent different resources. And again, the first 2 blocks are resources for recognition and resources for production. So in the first interface was labeling, where the person can see an initial translation and click on different icons to share an evaluation of the translation quality. This only requires their language resources for recognition, so it can sustain their agency while also remain easy for them to manage. And the next condition is a regular post editing, where the person can translate the sentence and then perform some edits by themselves. So this requires both resources for recognition and production, likely to sustain their agency to a higher extent, but starts to get more challenging because it involves language production. And the last condition is augmented post editing, where the person can translate and also access some paraphrases generated by large language models, and then perform their own edits. So this also involves some external language hints to sustain the person's agency while also help ease some challenge for language production. We hypothesize that all three interfaces will sustain non-native speakers' agency to certain extents, and the more resources are involved, the higher agency the person will have. And we also wonder how will this affect their communication performance, such as process and outcome. So we conducted an online experiment with 45 dietes, one non-native speaker and one native speaker, and they engaged in an information-seeking conversation on the topic of housing selection in the US. And the non-native speaker interacted with one of the three interfaces. And this was the task material that we provided to the participants. We collected people's conversation logs, post-task survey, and also an importance ranking of different items to measure how they aligned in the conversation. So our first result is that these three interfaces do sustain non-native speakers' agency, and the labeling condition were able to sustain agency to a moderate level, and the post-editing condition was sustain their agency to a higher extent. And looking at the conversation process, we do observe in the labeling condition, the dietic conversation less broad but more in depth. And in contrast, in the two post-editing conditions, the conversation is more broad but less in depth. And these led to a different outcome of the conversation. In the labeling condition, the two persons in the diet were more aligned with each other, but in the editing conditions, they were less aligned. So with these results, our key takeaway is that sustaining human agency in AI-mediated communication may introduce trade-offs to the other aspects of the communication process. So in our case, the non-native speakers, when they are trying to use resources and influence the machine translation outputs to preserve their personal agency, it seemed to have influenced how they engage in the conversation with another person. And so we argue that the choice of human-machine translation interface will be dependent on the priority and goal of the communication context. Should we sustain the person's agency to a moderate or a high level, or do we want to facilitate a very in-depth understanding or just an overview? And with that, I will conclude this talk and again acknowledge this work was supported by the National Science Foundation. Thank you.
Good morning, everyone. My name is Farnaz Zamiri. I'm a PhD student in computer science. I'm excited to share with you some early results from our exploration into how people select data that they consider more valuable for AI. This is a joint work with former students Jonggi Hong, Hyunjun Lee, and our advisor Hernisa Kasori. Every time we browse, click, or capture a photo, we leave behind a trail of data. And now we are entering a world where we can actually choose which of those data points to use to personalize models, fine-tune AI tools like ChatGPT, or teach a system what we care about. But here's the challenge. Most people aren't machine learning experts. So how do non-experts decide which of their data is more valuable for AI training? And what can their choices teach us about how people understand and interact with AI? One early example of people fine-tuning AI with their own data is teachable object recognizers. It's often used in accessibility settings, for instance, by blind users who take photos of their personal items to help the model recognize them. And this setup turns people into model trainers, using their own data to customize it, and that's what makes this setup a powerful lens for exploring our research question. Now, imagine you're trying to teach an object recognizer to recognize your favorite jar of cumin, not just any one, but the exact one sitting in your kitchen. You take 30 different photos, some from above, some from the side, some blurry, and some of them are perfect. Now you're told you can only keep 20 to train the model. Which 10 would you throw out here? All right, we have narrowed it down to 20 now, but now the challenge gets harder. You can only keep 5 photos. Now every photo has to earn its place. Do you go for variety, different angles and lighting, or do you double down on the most perfect image? And finally, out of all the images, you're asked to keep only one image to train your model. Now, this is the one image that defines what this specific jar of cumin looks like. And that's exactly what we asked 100 participants to do in our study. They took photos of everyday objects like snacks, drinks, or spices, and using our custom web tool, they trained a real image recognition model with 30 photos per object. Then we asked them to trim their data, first down to 20, then 5, and then just 1. We didn't tell them what makes a good training image. We just asked which of your photos will teach the model best and make the model more robust. So we knew which photos participants picked, but we also wanted to know what those photos looked like. So to find out, we manually reviewed each set and looked at 3 things: object size, background, and viewpoint. And this gave us another lens to actually interpret why some selections work better than the others. Now that we had all the selected subsets, we wanted to know how well did they actually work. So we trained the testbed model for each subset size, 30, 20, 5, and 1, and tested it on the participants' own test images. When we looked more closely at how model performance changed across subset sizes for each participants, we found 6 distinct trends, each telling its own story. For some of the participants, the trend was increasing, a rare but interesting case where smaller subsets actually improved performance. These participants worked with fine-grained objects and selected crisp, focused images with visible logos. They essentially filtered out noise. In the peak group, performance was best with 20 or 5 images. These participants added a lot of background clutter, enough to make one image unreliable, but not enough to overwhelm 20. Once we saw how people made their choices, the natural next question was, would algorithms do it differently? We tested that by running 3 automated selection methods on the same data. First, we used Microsoft Copilot, the large language model, and gave it the same image sets. Like a participant, it was asked to pick the photos that would make the model more robust. Then we used facility location, a well-known algorithm that selects data to be diverse and representative. And finally, we had random selection as our baseline. At the largest subset size, 20 out of 30, all methods performed similarly. And this makes sense. With more data, even less strategic selection still results in very robust models. But things got more interesting as the subset got smaller. At the 5-image level, models trained on human-selected data actually outperformed both Copilot and facility location. And at just 1 image, human-selected data was clearly best. Why? When we looked at the images, we saw that humans often picked very clear, sharp images, often highlighting the brand name or key features of the object. In summary, our study shows that even people without machine learning expertise can meaningfully select training data and often do it well. We discovered 6 patterns of behavior, each offering insights into how users interact with AI tools. These have strong implications for designing better interfaces for interactive machine learning. And we are preparing to share the dataset CrowdTima, which includes around 22,000 photos from 100 participants from our study, so stay tuned. Thank you very much.
Thank you, Farnaz. Thank you.
Hi, everyone. My name is Alan. I'm presenting some early results on a study that my collaborators from GWU and Tel Aviv University are working on to understand how users audit fairness and bias in AI chatbots. As has been so frequently noted in the past few years, Gen AI has some serious flaws with regard to alignment with human values, and more specifically concerning bias, unfairness, and risks, all of which pose a serious hazard as these technologies play a larger and more complex role in our daily lives. As such, the research community has expended significant effort organizing these biases, risks, and harms into frameworks that we can use when we study Gen AI. However, there is limited insight into how end users specifically understand these kinds of biases, how they assess for them, or how their perceptions of AI change when they appear. To help close this gap, we asked 2 primary research questions. 1, how do lay users audit Gen AI chatbots for trustworthiness and robustness? And 2, how does this auditing effort impact their trustworthiness perceptions of those systems? And concerning users' auditing strategies, we were specifically interested in capturing the issues that they seek out, the issues that they actually end up finding and flagging, in the interaction schemes that they leverage when speaking with the chatbot, as well as underlying reasons for why they select their strategies. And to that end, we built an auditing platform with a chat interface very similar to those of commercial models and tasked participants with ensuring that the model they interact with upheld a set of 10 principles related to fairness and trust that we compiled following a systematic literature review of prior work in the AI fairness, bias, and harm space. The high-level study flow consisted of an initial psychometric scale that captured participants' perceptions of fairness, trust, and risk in AI, followed by an interaction component with a chatbot. Participants prompted the chatbot seeking out potential issues, highlighted portions of the outputs that they found problematic, and explained their overarching strategies as well as what specifically they found problematic with their outputs. We collected 553 audits from 255 participants and conducted 17 follow-up interviews. We applied inductive coding to the conversation logs and free text responses, seeking to surface common themes and strategies in their approaches. For this presentation, I'll be overviewing the kinds of issues participants sought out, as well as some interaction styles that we observed. We find that participants seek a variety of issues, although each participant tends to focus on only one or two of these issues per audit. Many participants are concerned about factual correctness and the utility of the information that they find, typically looking to check that the chatbot is just able to output objectively correct information. Participants are also interested in seeking out harmful content and misconduct, typically related to physical harm, moral and ethical violations, or other offensive content. Other more nuanced concepts such as bias, expressed as non-neutrality or lack of diversity or depth in output, are also explored, as well as aspects of the chatbot's capabilities and behaviors, although to a much lesser extent. A significant proportion of our uncovered strategies were uncomplex and direct, with participants just straightforwardly asking questions of the chatbot in order to uncover potential problems. Even when asking about potentially divisive topics or seeking out harmful content, direct questioning was a common theme among all of them. However, some participants do take a more roundabout approach in their assessment, with some trying to indirectly surface potential problems through trickery or jailbreaking-like techniques, while others try to bait the chatbot into agreeing with problematic views, such as asking leading questions or getting the chatbot to engage in sycophantry using heavily framed prompts. The participants that we interviewed generally chose their strategy with no specific motivation, choosing to draw heavily on their personal backgrounds, recent events, or past interactions with AI as a jumping off point. These relatively shallow approaches to auditing are important to capture because, when coupled with the high self-confidence that participants placed in their own approaches, could result in users developing strong trust in a chatbot and accepting a biased output as truth. This foreshadows potentially severe consequences that might result from many participants' inability to operationalize harms or bias in a more nuanced, circumspect manner beyond impacts to their own typical use cases. We observed that prior experience, personal backgrounds, and mental models heavily shaped both their auditing strategies, as well as the impact that their auditing process had on their perceptions of the chatbot. And perhaps most significant implication is that shallow auditing, as a consequence of shallow understanding of how AI chatbots function, can lead to overconfidence in both these systems, as well as the user's abilities to identify and address flaws in these systems if they encounter them. Thank you.
Thank you, Alan.
So, hi everyone, I'm Jason Ding. I'm a first-year PhD candidate working with Professor Zhao Chen. And the project I'm going to present is towards human-AI alignments on the conceptual level. Generative AI-assisted hypothesis exploration and evaluation. Actually, this project is from my last internship at IBM Research, and we want to try to push it forward. So the open problem of the generative AI in idea generation is like now we are really excited about generative AI in this kind of high level, propose some interesting research questions, even towards fully automated research. However, now the generative AI is just a probability model, and it can generate something fun, but it cannot effectively select or evaluate the hypothesis or the research questions based on the current context. For example, maybe the research trend in 2024 and 2025, they are very different. And as researchers, we kind of know the difference in this trend. But at generative AI, maybe they have a cut-off knowledge at a certain point, so they can proceed. So there are many words, for example, recent works using large models to generate NLP research ideas, or the scientific literatures, hypothesis generation with both literature and data, and also let other kinds of work. However, currently there's no efficient work on or not enough work on selecting the hypothesis generated by AI. And we argue that effective hypothesis exploration should be a mixed initiative approach that integrates both the complementary strengths of human and AI. Because as human, we know more contextual knowledge. For example, what's the difference or whether there's some new word. And we can also chat with our cohorts. But AI, they just have maybe broader access to wider literatures. So the question is, how can we support human AI collaborative exploration of hypotheses? So we have 3 design goals. So we want to make sure the researcher as a user to balance both the breadth and depth of exploration. And it can also support the nonlinear exploration of hypotheses, because hypothesis just not step by step. There are many back and forth. And also, we want to enable the engagement with the relevant data, because as researcher, we are still very serious. We want our research is grounded with data, not just on the fly. So we did some formative studies, and here is our final outcomes. So we submitted a patent with IBM Research last year. So for example, imagine you are a data scientist and you are interested in income inequality with a very huge data set like the 2020 US census data. And you just put your internal research in the very broad research question like income inequality. And we can use this generative AI to generate multiple hypotheses. And also we provide the both the hypothesis and also the preliminary results generated by AI. So humans don't need to be involved in the visualizations. They just see that, and also we also retrieve related work with RAG, and then they can also dive into with this kind of knowledge diagram. And the next step is hypothesis evaluation, because when we explore such a wider space of hypotheses, we also need to evaluate that. And as I said, now the AI cannot evaluate all of them, or effectively evaluate all of them, because maybe different people have different preference of novelty or impact. They have different definitions. So they are the pre-work of a fully automated hypothesis evaluation with AI. And they mainly consider the novelty, impact, feasibility, clarity. So if we put both the hypothesis exploration view and also the hypothesis evaluation view side by side, we can see there can be something interesting, because different view can highlight different types of information. So hypothesis exploration is more like the depth and also breadth, while the hypothesis evaluation can evaluate the hypothesis across different coordinates, for example, novelty and feasibilities. And the good thing for this HCIL coordinates is we can do direct manipulation, manipulation on the conceptual level. For example, if we think maybe a hypothesis is actually more feasible than it looks like, or it's judged by AI, so we can modify the evaluation, we can also modify the hypothesis. And for example, we can also merge two hypotheses. For example, if we are in a symposium like here, we want to collaborate with other researchers, and we are interested in different topics, but we want to find some common ground. So the way we want to collaborate is maybe we can merge our ideas together to generate new ideas as an overlap. So we just build the systems, and both of them, and we also collaborate with other CS researchers to build this fully automated package as a backend. Thank you.